Sound design.
So can you estimate line array splay in the field without software while the riggers are waiting on you? This is the question that I posed in the last article that I wrote. And the short story is yes. If you have a laser distance measure, or I guess a really long measuring tape, and you measure these three things in the field, distance to the last row of the audience, distance to the first row of the audience, and distance to basically the rigging point from this position here under the array, then you can calculate average splay of your line array, which is not the whole answer to an optimized line array and optimized coverage, but it'll give you a really fast answer, which you can use in a pinch and is better than doing nothing. So this is going to be a slightly longer video because I'm going to be doing some drawing. I'm going to be trying to get into some geometry. But I want to do it step by step in case you want to do it along with me. I'm going to be using MapXT and Sketchup, but you could pretty much use any design software. You could even use pencil and paper. So the critical piece of information that we need to know here is target coverage angle. And what is that? Well, that is the angle that we need to fill with our splay here, with our line array, to fill this here. So if we have this audience and we have this speaker array and we know it's going to be hung at this height, then how do we quickly just decide what the average splay is so that we can fill this space properly? So I'll tell you, I was a little bit confused about this when I first started. I think I read through Bob McCarthy's book and I thought that target coverage angle meant this angle like this. So we can look at that and we can see that this line is 168.24. 168.24. And we can see that this one is 144.6 degrees. So if we use those measurements, it seems like the target coverage is 23.64. And so then we would see, oh, we have 8 splay angles here. So we'll take that number and divide it by 8. So it seems like our average splay is 3 degrees. But then if we put in 3 degrees to all of these boxes here, and we turn on their center lines, and we aim this array down so that it starts at the end of the audience there, vertical top, vertical bottom, we can see that our coverage is too wide. Okay, so this is not really the angle that we need, and this would give us the wrong result. So let's undo all of that. I'll delete these lines. So that's not target coverage. Target coverage is actually back behind the array because it's this slice of the pie that the array is filling. So I drew this already so I could just show this to you. So if you start at vertical top and vertical bottom and draw lines that basically go up here, and I just tried to cross through the speakers here, and now I need to zoom out a little bit, so I need to change these extents. So now you see a much bigger triangle here. So now you can see that it's really this angle right here, which is target coverage angle. So now if we take a look at this line at 168.57 and this line at 157.99, which I already have here, we can see that the target coverage angle is actually 10.58. And now if we divide 10.58 by the number of splay angles, how do I know how many splay angles we have? Well, I know that there are 9 elements here, 9 Lena boxes. 9 minus 1 is 8, so there's 8 splay angles in between these boxes. So target coverage angle divided by number of available splay angles gives us our average splay of 1.3. And this makes a little bit more sense now. I think the last number we used was 3 degrees. So now we should be able to put average splay into every one of these. And we can see I've got a total of 8 now, but I want a total of 10.58. So I'll add a couple of extra here until I get closer to 10.58. There's 10. Okay, so 11 degrees. So I'll call that done. And now when I turn these lines back on and I aim this array down, it should match pretty well. So I just wanted to show you where this came from because I used to be pretty confused about that. But let's go ahead and hide this and talk about how you figure this out without drawing these lines. Okay, so the way I've seen other people calculate target coverage angle is to basically subtract this top box down angle from the bottom box down angle. And one way you could do that is by drawing lines here. So I'll draw this one all the way out. And I'll draw this one all the way out. I'm basically just marking our starting points here. And now if I grab this array and aim it down, until I touch vertical top here, and now I have my first angle. So I could compare these two, but I started at 0 degrees, so I should just be able to look up here and see that I aimed down 11.43 degrees. So I'll go back to my calculator here and put in 11.43. And now I need to know this bottom angle. So I'm going to keep aiming down. And look at this angle again, 21.89. So 21.89 minus 11.43 is 10.46. Very close to what we got up here, right, with our first calculation. So that would be one way to do that, and then same process, divide by the number of splay angles, get your average splay, and then put that in. So this process is totally doable. The reason that I wrote the article and that I'm making this video today is that I also wanted some way to do this without software. Like, what if I show up in the field and I'm using some speakers that I've never used before, I don't have any experience with them, I don't have their software, I don't even know if they have software, maybe there's no modeling software available. Now that's becoming less and less common today, but I think it could still happen. And what if you wanted to figure this out in, 5 or 10 minutes instead of however long it would take you to go and get a computer, boot it up, download the software, learn the software, figure that all out. So let me reset this again and I'll show you how I do it. So I'm going to draw some right triangles here. I'm always using this point below the array as my reference, but I'm going to start at vertical bottom. So first row of the audience, draw up to this bottom speaker, down to head height, and then back over here. And you can see that I didn't draw that perfectly, but that's okay. And then I have another right triangle, which is from vertical top, last row of the audience, to the top of the array. If you can find this angle of this right triangle, which is pretty simple, and you can find this angle, then those are the same two angles you need to make this kind of calculation that we did before. So again, if you're in modeling software, this is pretty easy to figure out. You can just look at the attributes of these lines. But if you're out in the field, you might want a little bit different method that doesn't use software. So I'm going to switch over to Sketchup now to talk about how you might do these measurements in the field. So you can see I've drawn in some helpful little lines already, and you can see these guys, but I'm going to hide these guys for a second because I don't want any of my lines to snap to them. So let's talk about how we get each of these measurements. Let's say that I'm going to stand here. I'm going to measure from here to the front of the audience. Okay, so I know that that's 20 feet. Now, how do I find the height of this triangle? Well, the array's not up there yet, so I can't actually measure this here to here, but I know that this point up here is 20 feet. That's where the rigging point is going to be, and maybe I should actually put that point in there. Okay, so the rigging point is 20 feet up, and now if I just know the array height and the listener height, then I can know this piece in here. So how do I figure out the array height? Well, it's pretty easy to estimate if you just take a look at the height of one element. So here is the speaker that I'm playing with. It is 8.38 inches high. Array height equals 8.38 inches times 9, the number of elements that I have, divided by 12 inches to give me feet, which is 6.285 feet. So my array is about 6.285. Let's just see how accurate that is. So here it says the array is 6.71. So slightly bigger than I estimated because there is some space between these elements. And this is probably also taking into account this bumper up here, which I'm not measuring, but I think it's still good enough for an estimate. So back here in Sketchup, if I've said, okay, I know that the array is 6.29 feet tall, and I know that head height is 5.2, then I can pretty easily just subtract those two. So 20 minus 6.29 minus 5.2 is 8.51. So this is going to be the next piece of information that I need. There we go. 8.51, just as I calculated. And I'll just draw the last line in as a visual aid, but this isn't what we would measure in the field. So all we need is these two sides because this is a right triangle. So 20 and 8.51. Now I'm going to open up a right triangle. Now this page is a little bit annoying because it has these ads over here and stuff, but I like that it kind of updates quickly and dynamically. So A and B, 8.51 and 20. 8.51, 20. And you notice I have this set to two sides. And this tells us that internal angle that we need is 23.05. So I'll put this back here on my notepad. And now we can go and measure that other triangle. So to solve this second triangle, I need this side over here and this side all the way along here. And I already have all of those measurements. So all I really need to do is take 20 and subtract this guy right here, 5.2. So 20 minus 5.2 should be 14.8. And I'll go ahead and put that in. Okay, so that piece of the triangle, and then 20 plus whatever this is, $70, and I'll just draw this line in for visual aid. And another one from here. Okay, so now you can see this complete big triangle. And now I can just solve for that angle again. So 14.8 and 70. And now I have an internal angle here of 11.938. And the result that I get is 11.11, not too far from these first calculations that I got here. So 11.11 then should be this angle here of these two lines. And let's see what happens if I draw these lines all the way out. So I'll take my protractor, start here, and yep, it says 11.2. So that is the target coverage angle that I was looking for. And back here in my notepad, then I might say divided by 8 to give me average splay of 1.38. What do we get before? Yep, very similar, 1.32. So again, I would round down to 1. Let's go back to mapXT. Let's put in 1 in all of these. And we don't need 8, right? We need a total of 11.11. So let's keep putting numbers in here until we get up to 11. And we even know the down tilt already, right? It is 11.93. Applying close. Turn on our center lines. And there we go. You can see that the aim is a little bit too low. Again, this is probably has to do with the tiny offsets because of the bumper and the ray's a little bit longer than my estimate. But you can see we did pretty well here. And it took me a little while to get through that because I was showing it to you guys step by step and we were taking these measurements. But if you were ready to go with this, you could just draw this on a piece of paper, take this measurement and this measurement, and then know the depth of your audience playing, and you could figure this out really quickly and get average splay. And what might the result of this look like? Well, it's not going to be great, right? Because this isn't optimized. We would need to do some more work manually to optimize this. And we could do that, and I cover that in detail in Pro Audio Workshop Seeing Sound. But I think this is still a better, fast method to go with in the field than just guessing or just leaving it all at 0 or something weird like that. And I know that sounds really silly, but man, when I first started using line arrays with other people and we really didn't know what we were doing, we were guessing all the time. We had all been to some trainings, but we didn't really know what we were doing. So I'm happy I can share this with you, and I hope this helps you out of a jam at some point. Okay, I'm going to talk a little bit longer because there's a second part of the article which gets into how to do this with audience planes that are not flat. So what if instead of this guy being flat, he had an incline to him? So let's say that it goes up to 10 feet in the air at the end. Okay, and I'll just get rid of these for now. We can actually use a very similar process. We just need to solve this triangle now instead of that other right triangle, which was a little bit easier. So this will be take maybe 1 or 2 extra steps, but now we need to know the height of this side here instead of that big right triangle that we had before, because we again need to find this internal angle over here. So let's go back to SketchUp and update our thingamajig. Okay, so now I have my inclined audience drawn in, and now I need to draw in and solve this triangle over here. We can still use our right triangle solver, but now we need to know this height over here. And I think we already have all the pieces that we need. We know that this point right here is 10 feet in the air. We know that this point right here is 20 feet in the air. 20 minus 10 is 10, so this piece should be 10 feet tall. And we already know the length of this piece because we figured it down here. It's 70. So we've got 10.04 and 70. Let's go back to our right triangle. 10.04, 70 gives us this internal angle of 8.16. Now we go back to our notepad calculator, and instead of 11.93 like we had last time, we'll subtract our 8-degree number from our new triangle. Now we have a total target coverage angle of 14.88, right? So the space that this needs to cover now that we've got an inclined audience. And then we'll divide by available splay angles again to get an average splay of 1.8. Now, remember, we don't have 1.8 in our splay, so we might round up to 2 this time and then subtract some and see if we can get down close to 14.8. So let's try that. MapXT, here's this guy. All of these are 2, but we want 14.8. So right now we're at 16, so let's subtract some from the top. Okay, that's pretty close. 14.8 is close to 15. So apply and close, we'll look at those lines again, and I'll re-aim this guy so that it's starting up here. And actually we could figure that out, right? So we know that it should be a down angle of 8.16. So back over here, it looks like it's going to be a little bit too much. Yeah, so it goes a little bit too far down. I'll just readjust that for our benefit. And it looks like we did pretty well. And we can take a look at the prediction here and see that, again, it's not great, but better than doing nothing, right? And probably better than leaving it all at 0 degrees. So that's how I quickly estimate target coverage angle and then average splay for a line array in the field. And you can do it without software in a matter of minutes with just a laser disto and a calculator. Let me know if you've tried something like this. Let me know if you saw me do something wrong. Let me know if you have a better way of doing this. I haven't seen anyone else doing it this way, and I'm always trying to improve my methods. So thanks, and comment on this video and let me know. Sound design.